Okay, in this video, we're going to be doing Calc Problem Set 115. The problems and a playlist are in the description below. Let's see what we're doing. Given that f of x is 4x to the fourth minus 8x cubed, how many extrema does f of x have? Okay, so it's kind of interesting because usually it's like find the max and min or whatever, but this is just in general how many. So we're going to find the derivative. So 16x cubed minus 24x squared. We're going to factor that. So take an x squared out. You could take an 8x squared out, but it doesn't make a difference in terms of like the procedure for solving. So the zeros of that are at 0 and at 24 over 16 or 3 halves. So we'll make a sign chart. And we got to test regions here. So negative a billion, let's say, is going to give us a positive and a negative. So negative overall. If we, so 0 is it comes from x squared, which has a multiplicity of 2. So there's not going to be a sign change on your chart, but you could also just test like 1. And if you plug 1 in, you get 1 times a negative, which is still negative. 3 halves comes from a factor that has a multiplicity of 1, which is odd. So there will be a sign change there. So you're definitely going plus, or just plug in a billion. We get plus. So this is why this is, I mean, not a trick question because you should just do the math, but there are 2 critical points, but there's only 1 relative extrema here. There's a relative minimum at x equals 3 halves. So since we're looking for how many, the answer is there's only 1. All right, next up. Given that the velocity of a particle moving along a vertical axis is given by v of t equals 8t plus 3t squared. Find the average velocity on the interval 2 to 4. All right, average velocity. What I like to do on a problem like this, where they ask me for the average blank, is in my mind, and here I'm actually going to write it down, is replace average blank with average value of blank. We're looking for the average value of the velocity function, which will be the integral over the interval. So let's write that down. We're going from 2 to 4, 8t plus 3t squared dt, and then over 4 minus 2. So replace average blank with average value of blank, and you will know how to solve the problems. It's a little less confusing, I think. All right, let's do it. So 4 minus 2 is 2, so there's a 1/2 on the outside. And then reverse the power rule twice. We get 4t squared plus t cubed. We're going to be plugging in 2 and 4. So it's 1/2 quantity, and then open a quantity for when you plug in 4. It's going to be 64 plus 64 minus quantity. Plug in 2, and we're going to get 16 plus 8. So we're doing 1/2 of 128 minus 8. 16, 24. What am I doing? Minus 24. So the easiest thing here to do is really just do half and half. So it's like 64 minus 12. So this will be 52. And that is the average value of velocity. It's the average velocity on the interval. All right, next question. If f of x equals 2x squared minus bx plus 3, and the tangent line to f at x equals 2 is parallel to the line through 0, 3, and 4, negative 1, what is the value of b? Okay, so let's just find that slope first. So it's going to be negative 1 minus 3 over 4 minus 0, which is negative 4 over 4, so negative 1. Let's find f prime. So f prime is going to be 4x minus b. Now we're interested in f prime at 2, so let's plug in 2, and we'll get 8 minus b. Oh, sorry. Well, yeah, we will get 8 minus b, but like we're basically in the problem we're trying to solve where f prime of 2 is equal to negative 1. So 8 minus b has to equal negative 1, and then solve that. So we get the b is equal to 9. That's the value of b. I don't know. That problem, I think when I was talking about it, I made it harder than it actually was. All right, new problem. If f of x is x cubed minus 6x squared plus 9x plus 3 between negative 1 and 2, what is the range of f? So when we're talking about range, we're talking about all the possible y values on a closed interval. I'm going to use the candidates test to find the absolute max and the absolute min. So I need a derivative. So that'll be 3x squared minus 12x plus 9. You can take a 3 out and get 3 quantity x squared minus 4x plus 3. We can factor that into 3, the quantity x minus 3, x minus 1. Our critical points then are going to be at 1 and 3. Okay, so we're looking for the absolute max and min on a closed interval. That is, I call it the candidates test. I think old-timey AP stuff calls it the closed interval test. Probably both are acceptable. So f of x is continuous on -1 to 2. Therefore, the absolute max and min will be at an endpoint or a critical point by the candidates test. All right, so now we have to actually do it. I'm going to make a table so that I can evaluate the function at the endpoints and the critical points. One key thing here is that 3 is a critical point, but it is not on the interval, so we don't consider it. And you definitely don't want to consider it because it may actually change your answer. Okay, so at -1, we're going to get -13. We're plugging into f of x. Don't mistakenly plug into f prime. I see a lot of people do that. If you get a lot of suspicious zeros as you're plugging in, you should think like, wait, am I accidentally plugging into f prime? So at -1, we get -13. At 1, we get 7. And at 2, we get 5. So the biggest value in there is the maximum. So y equals 7 is the max. The smallest value is the minimum. So -13 is the minimum. Let's write those down. Although we don't really need to, we just need to find the range. But still, I'm going to finish the candidates test. So absolute max is 7 at 1. Absolute min is -13 at -1. So our range will go from the minimum to the maximum. Our range is -13. It's less than or equal to y, less than or equal to 7. There you go. That's the whole problem set. I hope this was helpful, and good luck.